Now let's take a look at each of these lobes to appreciate more fully the functions that are associated with them, as well as the various subdivisions of each lobe. And we can also explore, as we move through each lobe, what might happen if there's a lesion within a specific area of a lobe. So here, we're looking at the primary motor cortex. This is shown right in through here in green. The primary motor cortex is associated with the gyrus that's immediately anterior to the central sulcus, and this is the precentral gyrus. We have the famous homunculus associated with the primary motor cortex. And the little man, the homunculus, demonstrates the density of upper motor neurons that are going to control the musculature of various regions of the body. So we see a large area here mapped out for the face, because a large number of motor neurons, upper motor neurons, are going to control the muscles of the face. We also have a large area here mapped out for the hand, and again, a large number of motor neurons are going to control the fine, delicate movements that are associated with this part of our anatomy. This homunculus does extend over the top of the cerebral cortex, over the top of that precentral gyrus, and continues on the medial aspect. We'll see that continuation on the next slide. An important aspect about motor control is that the motor neurons on one side, here we're looking at the left precentral gyrus, they're going to control the contralateral muscles, those that lie then on the right, in this case. What might happen if there's a lesion within the precentral gyrus? That will cause contralateral paralysis or paresis, and because you are damaging and destroying the upper motor neurons, you may very well see a Babinski response depending on the location of the lesion. So if the lesion is in this area specifically, you would have contralateral paralysis or paresis of the hand, for example. If we continue our view here on the medial aspect of the precentral gyrus, and again that's shown in green, we can see the buttocks lie here on the superior aspect of the precentral gyrus medially, and then you can start to see the lower extremities continue distally so that the feet are approaching the cingulate gyrus that's along here. And so if the stroke is in this area and you have a lesion in this area and you're unable to have upper motor neuron control of the distal extremity, of the lower extremity, then that's when you can see a Babinski response as well as the contralateral paralysis or paresis of that associated anatomy. Another area of interest that I want you to understand is that of the premotor cortex. The premotor cortex lies anterior to the primary motor cortex, and we see it's a small area here, but it's essential in the programming of motor events. And so this programming will then cause these neurons that reside in this territory to activate prior to the primary motor neurons that are within the precentral gyrus. A lesion of the premotor cortex is associated with apraxia. Apraxia is a motor speech disorder. This can be associated with other lesions in the frontal lobe. Our next area, the frontal lobe, is that of the supplemental motor cortex. We see it identified, again, anterior to the precentral gyrus, and it's involved in the planning of complex motor movements. A lesion of this cortical area can cause apraxia as well. Another area within the frontal lobe is the frontal visual field cortex. This area right in through here. It's even a bit more anterior to the other areas that we were describing, that I was describing for you. It's involved in the coordination of voluntary movements. A lesion of this small area can result or will result in paralysis of conjugate gaze to the opposite side. And this is discussed in another presentation, what conjugate gaze is and how that circuitry works. Another important area within the frontal lobe is this area in blue. This is Broca's area, shown right in through here. This is the area of the frontal lobe that's involved in word production or motor speech. A lesion here results in expressive aphasia or non-fluent aphasia. Lastly, within the frontal lobe, I want you to understand the prefrontal cortex, and we see that area here. This is the area of the cerebrum that takes some degree of maturation to become fully functional. This is involved in executive functioning, and one of the functions under this heading would be that of problem solving. It's also involved in making day-to-day multiple judgments. Many times we make very, very good judgments or decisions, and these judgments, as we mature, tend to make us make the right choice or the right decision. And another aspect of executive functioning is that this is the area that allows us to plan. It also drives behavior and emotions. It's not the only area, but behavior and emotions are modulated by the prefrontal cortex. And then an area of the prefrontal cortex is involved in olfaction, the olfactory pathway.